We are going to begin our discussion on complex numbers by discussing real numbers and reminding ourselves of the things we know about real numbers. So, real numbers can be divided into two categories. They are either irrational numbers, such as pi or the square root of 2, those are irrational numbers, or rational numbers. Most of the numbers that you are accustomed to doing math with, are rational numbers. Any number that can be written as a fraction is said to be a rational number. Now, rational numbers can also be subdivided into integers, such as -1, 0, 10, those are all integers. And all of the other numbers, which we just say are non-integer fractions. So these are all of the rational numbers that have to either be written as a fraction, or a decimal that ends, or a decimal that repeats. And then we can keep going with this dividing up into categories and subsets. But let's talk about complex numbers now, because complex numbers are actually numbers that have both a real part and an imaginary part. So just as rational numbers are a subset of real numbers are a subset of complex numbers. Now, we're familiar with real numbers, so let's define what an imaginary number is. An imaginary number is any number that contains the square root of -1. For example, the square root of -5 is an imaginary number because it contains the square root of -1. I can rewrite the square root of -5 as the square root of -1 times 5, or the square root of -1 times the square root of 5. Now, because all imaginary numbers contain the square root of -1, we have a special symbol for the square root of -1, and it is I. So I equals the square root of -1. If I have, for example, the complex number 4 minus the square root of -3, I would want to rewrite that complex number in terms of I. So I would write it as 4 minus, and then square root of 3, I. Because it's the square root of 3 times the square root of -1. Now, notice that the I is outside of the root sign. It's very important that I write it outside of the root sign. All right, so this is the complex number 4 minus the square root of 3i. Now, my complex numbers do not always have to have a real part, and they do not always have to have an imaginary part. For example, 12i is a complex number whose real part is 0. 0 plus 12i. The number 14 is a real number whose imaginary part is 0. Whenever we write a complex number, it is customary to write the real number part first. So for example, if I have 5i plus 6, I would really turn that around and write it as 6 plus 5i. You always want to write the real part and then the imaginary part. Now, just as we can graph real numbers on a number line, we can graph complex numbers on a number line, but it takes two. It takes a number line for the real numbers and a number line for the imaginary numbers. So let me show you what that looks like. This is my real number line. And then this is my imaginary number line. So if I want to graph the complex number 2 minus 3i, then I would go 2 places on the real number axis, and then -3 places on the imaginary number axis. Let's do one more. Let's say I want to graph the number -1 minus I. Well, that's -1 on the real number line and -I on the imaginary axis. Right, now, one more thing we want to do in this introduction video is to talk about the powers of I. I, of course, is the square root of -1. What is I squared? Well, I squared is just -1. Remember that when we square a number, for example, the square root of 5 times the square root of 5. Now, we like to say that's the square root of 25, all right? But really, it's the square root of 5 squared. And so that's really just going to be 5. The root sign just goes away. So the same thing is true here. I squared is going to be the square root of -1, the quantity -1 squared. So it's just -1. I cubed is I squared times I. Well, since I squared is -1, then I cubed is -I. And then I to the 4th can be written as I squared times I squared. But I squared is -1. -1 times -1 is +1. So I to the 4th is +1. I to the 5th can be written as I to the 4th times I. Well, since I to the 4th is +1, then I to the 5th is +1 times I, or it's just I. So notice that we have cycled right back up to where we started. I6, I to the 6th power would be I to the 4th times I squared. I to the 4th is 1, so it would be the same thing as I squared, which is -1. I7th would be the same thing as I cubed, which is -I, and so forth. So what about something like I to the 14th? Well, I to the 14th can be written as I to the 4th times I to the 4th times I to the 4th times I cubed. Each of these I to the 4th is just 1, so I've got 1 times 1 times 1 times, oh sorry, not I cubed, I squared, times I squared, and I squared is -1, so I to the 14th is -1. All right, what about I to the 53? Now, I to the 53, I can write that as I to the 52 times I. Now, why did I pick I to the 52? Well, 52 is the closest number that's divisible by 4 to 53. 4 will go into 52 evenly. It goes in 13 times. All right, so 52 is a multiple of 4, which means that it's going to be the same thing as I to the 4th, which is just 1. So this is going to be 1 times I, which is just I.